It's off?
No.
Hello? Hello? Yeah? Okay. All right. Okay, everything. Hello, everyone. Do you hear me? If I can just ask everyone to sit down so we can begin this session. Hello, my name is Sana, and I am the director of Womanpreneur, and I'm very delighted to welcome you today at this event. So I will start by giving you a little bit of an overview about this event, and the idea behind it. So basically, as you know, we are living today in a world which is impacted and influenced by the tech and digital revolution. So we are going from internet to BrainNet, from bitcoins to blockchain, from virtual reality to augmented reality. We're going from robotics to gene modification. We're going from internet of things into internet of everything. So the tech revolution is definitely impacting our life of today, and is going to transform our life of tomorrow. We are fascinated by all these innovations, and we are fascinated by the power that internet is providing to all of us. Today we feel more powerful because we have the access to this internet. We've seen what happened with the Arab Spring. It was thanks to the online activism that young people turned down dictatorship that controlled their countries for years and years. When I was in China, I was so fascinated by the presence of technology in every single aspect of their lives. I was fascinated by the facial recognition that allows the people to pay less taxes if they are good citizens. So this shows you the impact of technology. And actually, the lives that we know today will be completely different tomorrow. So the challenge is how this technology is going to control our lives. How is it going to change our policies, our systems, our infrastructures, our justice, our democracy, and above all, the human conditions. As far as women are concerned, which is why we are here today, technology is possible to contribute and change the course of history for women. But it could also create more inequalities for women. So this is why we are here today, is to explore, examine, and understand how technology is going to change the history of humanity, and especially the history of women tomorrow. So 15 years from now, we will have 50% of jobs will disappear. And these are jobs that women are likely to hold. So the question is not only about women having or accessing or understanding or navigating the technology. The question is having women deciding in the process of creating the technologies, deciding on how to use these technologies, and mainly have also the power over that. In so many countries, women don't have access to technologies, and they are completely excluded and marginalized from this field. You've seen what happened with Me Too movement, which is a very powerful movement, that gathered the voices of women from different countries. When I was in New York, I was asked about the Me Too movement and how it represents the voices of women in different countries. I said Me Too movement represents voices of only an elite of women. If you go to Palestine, and you go in marginalized areas where women don't even have access to internet, they cannot use Twitter, and maybe they don't even know what is Twitter. So this is basically to give you just an overview about our event. Womanpreneur was created and has been created with a vision and a mission to disrupt the change, this innovation and technology change, and put women in the heart of this revolution. We have other exciting initiatives. So we're going to launch different training programs on digital innovation for women. So keep your eye on our social media to get updated, and also you can sign up to our newsletter. So tonight we will explore, question, examine, and understand what is the place of women in the field of robotics. We have amazing speakers who will share with us their experiences, they will share with us their point of views, but also they will debate with you and hear from you. This is a first of its kind event, and it would never have been happened without the support and the help of our partners. So I would like to thank first BC, who was our sponsor for the evening, for supporting us. This is among different initiatives that they support. Emmanuel, who unfortunately couldn't make it today, she is basically the representative of BC for Womenpreneur, and she has been a great support system. I would like to thank our host, Digitizer, who opened their home for us today. Thank you so much. I would like to thank Philip, who accepted since the day one when I asked to do this initiative. He said, yes, let's do it. I would like to thank Ricardo, who is an amazing system of support. And I would like to thank Adelaide. I don't know where she is. She has been amazing, helping us with all the logistics and so on. I would also like to thank our company's partners, Robotic Human Research Center, Space Application, and Bright Knight, who happily shared their technologies with us tonight. And I would also like to thank our inspiring speakers, Irene and Leonard, who will kind of share with you their experiences in a few minutes. And last but not least, I would like to thank my team, Sana, Christina, and Teresa, who have been working very hard on making this event a success. So now I will give the floor to Philip, who will talk to you a bit about the space. They have an event happening on 26th of June about digital. So I'll let him to take the floor. Enjoy the evening.
Good evening, everyone, and a very, very warm welcome to you all. Good evening, ladies. Good evening, gentlemen. I'm very proud to have one of the fighters of digitalization here today, and it's obvious that you are more than welcome to use this space as much as you want. This space has been created in the middle of the 7th poorest communes of Belgium. There is no poorer place than Digitizer. Yeah? If you take the average income of everybody around, you won't find a poorer place. And therefore you don't have to go to Africa to find people who have difficulties with digitalization. You just have to take the underground, and you will see when you leave here tonight. There are people there who have no access to digitalization. That is one of our main drivers. We want to help digitalize Brussels, and we want to make this accessible to anyone. Anyone with the wish to understand is welcome to come here at Digitizer. That is one very important task that we have. The second important task is that we want to facilitate entrepreneurship, because if you don't have a degree, the only way to get out of poverty is by being an entrepreneur. Your drive, your commercial drive, your dynamic ideas is the only way out you have. And this is also a place for entrepreneurs who have ideas. We bring them in contact with the public aid of the region of Brussels, with experts. We coach them, and we help them to go from their initial idea to their first invoice, to their first customers. Yeah, that's what we do. We love to do that. We do that on, this is a private initiative, but assisted by the region of Brussels. They assist us, and also by different corporate organizations like Sofina and Engie. Yeah, with their assistance, we were able to have this place, and we've been working in this place for more than 2 years now, building it up, making it available to anyone with ideas. The ground floor is for free. You can come here from Monday to Friday, from 9 to 5. You can come and work here for free. And once you have defined your idea, you can go up and have a more secure environment, or a more environment where you can focus with 2 or 3 people around the same idea. And then you take like an access card, and your access card is 150 euros a month. And then for that you have access to the showers, to the food, to the coffee, to the 24 hours by 7 days a week. Yeah. So very warm welcome. The topic of the day is wonderful. It's all about digitalization. It's about enabling people to do some business. So it's the perfect place to do it in Digitizer. Thank you very much for being here.
So just want to invite you to use this screen that you have here on your right, which is your way to ask questions to the different speakers during the event. So you just go with your mobile to slido.com, you put this hashtag womanpreneurrobot, and then you have a space where you can contribute with ideas, or you can contribute with questions, and you can give also feedback about this event. So feel free to really use this. Yeah, of course. So you can really use this space. There is questions, ideas, and feedback. Feel free to use these three aspects of these interactions. And your questions are going to appear on this wall live. You can also upvote the questions that you like, downvote the questions that you feel less interesting. And with this, the speakers are going to be able to have a more interaction with you. That's it for me.
Hello, everybody. I am Teresa, and I'm the Global Coordinator at Womenpreneur. Welcome. First of all, let me apologize on behalf of Mrs. Van Dam. She, from Dell Technology, she was supposed to be here tonight. The next session was supposed to be a tech lab, but unfortunately she had an urgent business trip, so she could not join us, but no worries, we got you covered, because the next session will be as much interesting, because we have with us tonight Leonard Vierendels of Brubotics, which is the Human Robotics Research Center of the Free University of Brussels, which, as the name says, makes research on human robotics with applications ranging from collaborative robots, bionics, prostheses, soft robots, AI, AR, VR. But I will let the floor to him to explain to you more about this interesting field. So please welcome to the stage Mrs. Vinicius. I'm sorry, but...
Thank you. So, so robots. Who here has already seen a robot before today, of course? Okay, quite a lot of people, that's interesting. Who here has already bought a robot? That's not that many people left. Okay, interesting. So robots is obviously something that's quite a lot of hype about, certainly the last few years actually. Although I think AI has now surpassed the robot hype probably. And robots is something that has been in our imagination for a very, very, very long time. The ancient Greeks, they had myths and legends about robots. The Chinese had some myths and legends. The Norwegians had them. Leonardo da Vinci actually designed one of the very first humanoid, so human-like robots. So it's something that has been in our imagination for a very, 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 very long time. And people have the wildest expectations of robots. When the very first industrial robots came to the market back in the 50s, 60s, this is the Unimate by General Electric, people had the wildest expectations. They were expecting, hey, soon we will have robots that will prepare our sandwiches at home. Now, unfortunately, I did not have a robot like this at home this morning to make me my sandwich, and I'm not sure if it's the case for you, but I doubt it. So just to show that people have always had wild expectations about robots, whereas in truth, robots were not able probably to meet up to those expectations. However, things have been changing and technology is advancing, and of course we are seeing rapid progress in the field of robotics in the latest years. Now, it still is incredibly hard to build a robot that is, for example, as capable as our human body. Our human body is capable of doing all kinds of amazing things. No, I cannot do those things, but okay. Some people at least can do these things. And it's not hard to see why it's so difficult to build a robot. You need to have a system that's fully coordinated. You need to have muscles that are super lightweight, super efficient, but capable of generating enormous amount of forces. And so it's very difficult to recreate this hardware, but also on the intelligence side, of course. And yeah, it's normal. I mean, it took us millions of years of evolution to come to this point where we are able to do these things. So it's normal that we cannot just replicate these into a robot. So what we believe at Brubotics, we are the university, the Vrije Universiteit Brussel, the robotics lab, or the robotics research center of the VUB. And so we really believe in what we call human-centered robotics. Robots that combine the strengths of where we try to combine the strengths of humans and robots. So we try not to have robots to compete against humans, or we don't try to build robots that are better than humans. We try to see how can humans and robots how can they collaborate and how can they make each other stronger. So we try to do this at the VUB by collaborating with several research groups, because if you want to do something innovative in robotics, you need to collaborate. We have at our university more than 120 researchers working on robotics, and we have quite a long tradition also in robotics. We had actually the very first artificial intelligence lab in Europe, or in mainland Europe, although the UK will soon no longer be part of Europe, so then we can really say that we were the first of Europe. So we are the first AI lab in continental Europe. We had already in the 90s first robotics lab, and then we also started Brubotics to basically group together all research on robotics. As I said, it's over 120 people, and what we really try to do is work multidisciplinary. If you want to be innovative in robotics, if you want to do robotics at all, you need to work together across disciplines. So we have, obviously, we have engineers, we have people from artificial intelligence, but we also have social scientists who look at how do people and robots, how will they collaborate, how will they work together, do people want to work together with a robot. We have human physiologists who look at what's the impact inside the human body if we use, for instance, exoskeletons or bionic prostheses, what happens in the brain, for instance. We have aging studies who look at, okay, what's the living environment of older adults, and how can we help these older adults using robots. So we really try to bring together a lot of different disciplines to think about robotics, and that's really what's necessary if you want to be innovative in this domain. Now, that's really what we try to do. So we try to improve quality of life through human robotics. I have brought some robots with me that you can come and check out later during the reception. So we work on quite a lot of different topics. This goes from social robots to exoskeletons, bionic prostheses, rehabilitation robotics, augmented reality, virtual reality, collaborative robots. A lot of different topics come together. I picked a few where actually women are working on at our place. Now, robotics is not a field where we see a lot of women. Yeah, I'm not a woman myself, as you have noticed. Normally, my female colleague had to be here, but she could not make it. But I tried to sum it up a little bit for you. So we have, for instance, in the robotics engineering, we have about 20% only of our researchers are female. However, in our steering committee, that runs Brubotics, let's say, the representation is a bit better, because in the non-engineering fields there are more women present. So it's a bit, yeah, we try to work on having more female researchers, certainly on the engineering side, and we're also encouraged to do so by actually the European Union. If we want to apply for a research project, having some female researchers is very beneficial for your chances of success. What we certainly do not have a lot is women entrepreneurs. We have a very low percentage of researchers that want to start a spin-off company and become entrepreneurs, and so we obviously also have a very low percentage of female entrepreneurs at the university. I've taken a look at all the spin-offs of the VEB, and I think I could count the number of spin-offs where there was a female co-founder on one hand. So there's still some work to be done, but we're working on it. Now, to give you a bit more idea of the type of research that we do. So as I said, I think I highlighted, I took 3 subjects that we're working on and where some of my female colleagues are actively involved in. So first example of how we can use, and that's probably the best example of combining the strengths of humans and robots, are these exoskeletons. So this is a lower limb exoskeleton made for revalidation or rehabilitation purposes. So this can help people who are paraplegic, who can't walk again. We'll try to make them walk again, or people who had a stroke, learn them to walk again using this type of exoskeleton devices. But we can also use them in the industry to help people who need to work in non-ergonomic ways, or who are dealing with heavy loads, for instance, and need to carry heavy loads. And we can also use exoskeletons to help them there. And this is really, as I said, a great example of combining the force and the durability of a robot with the dexterity and the creativity of a human. And so we have Marta, who's an Italian colleague who is leading this research domain. Another example is our bionic prostheses, and I have some of them with me today. So when you build robots, you can also, of course, try to use this technology to help humans directly. So we try to use a robot leg as a prosthesis. So this is a person with his own prosthesis. You see, there's a lot of limitations to current prostheses, and we try to actuate, to motorize, to add motors to these prostheses and really make them bionic prostheses. They're basically robot limbs, of course. This is some research that's super challenging, of course, because here it's really about combining the hardware. We need to deliver hardware that is capable of delivering the high forces and so on that we need indeed to propel a human body forward. But we need to marry this with the intelligence to, for instance, detect, okay, am I walking on a slope? Am I walking normally? Am I walking up a staircase? We need AI to detect what we are doing at the same time. And so we need to combine this hardware and software together, which is quite a challenge. And a final example of some of the research we are doing is on, actually we're trying to build self-healing robots. So what we'd like to do in robotics is use more soft materials. For instance, for our prostheses or exoskeletons, these are devices that are in close contact with humans, so we preferably want to make them out of softer materials. However, a soft material obviously is very fragile and will be damaged quite quickly. So that's why we are looking into self-healing soft robotics material. So when I make a cut in this material, it will heal itself up to 99% or something. So hopefully we'll one day have robots with a real skin, let's say, that can heal itself on its own. And talking about entrepreneurs, so we're not only doing research, we're also trying to bring the research out there. So this is an example of a spin-off company that we're now in process of setting up, Axillus Bionics. It will bring to the market some of our bionic prostheses that we developed. So we've been working for more than 10 years on the technology, and now we feel that we are ready to take the next step and bring them to the market via a spin-off company. However, it's very difficult to bridge, let's say, the gap between research and the real market. Certainly to find funding, it's not easy, but I guess that's the same story for all entrepreneurs. So for us, the future is about humans and robots collaborating, joining forces. I've shown you some examples very quickly of some of the research that we are doing. and I hope this will become much more important in the future. This is really the future of robotics. It's about combining humans and robots. Now, one thing that's maybe becoming a bit of an issue also is the lack of women robotics engineers, for instance. Because when we design prostheses, we tailor them on male, how do I say this, on male examples. So we use data collected and to know, okay, how much force does an ankle need to produce, how big can it be, and so on. We model this based on male examples and not on female examples. So having more female roboticists would, of course, help in making sure that we create robots that can help everyone and not only males. And what I a lot of in our case at least, there are a lot of women involved in the more the social side of robotics and helping us to bridge the gap between the hard engineering and the humans. So we have our social scientists are mostly women, and they play a crucial role in making sure that if we, for instance, design an exoskeleton, we also want to make sure that people want to wear it, and that's actually a very crucial role where we find that women are very capable of doing that. Now I'm trying to see what questions you are asking me. So are smartphones robots? Well, yes, it depends on what you define to be a robot. Of course, there are a lot of different definitions. The academic world hasn't set on a definition of what is a robot yet. So there's still a lot of discussion on that. But in general, I think you can say that anything that has a sensor that thinks about what the input that it receives and then can act and deliver a certain output, but that can influence its environment, is a robot. So a smartphone cannot really influence its environment, not directly at least. It does not have an arm or something to grasp something, let's say. So that's why probably a smartphone is not really a robot, at least according to that definition. Anything else? Yeah, built-in chips in human bodies. It's already hard enough we don't know yet how our body works. So enhancing our body or adding chips to our body to improve it, we're not quite there yet. First, we need to understand how our own body works before we really can make that step. And we see that, for instance, also in our prostheses. It's so hard to replicate a human body. It's even harder to have a robot and a body communicate with each other, for instance. So we cannot accurately measure the brain signals to steer prosthesis, for instance. So we need to use other tricks. So adding chips to our brain or anything, we're not quite there yet. This is still also on the hardware side. There's still a lot more work to be done before we will be able to do that. And so the last question I see, so about the patents. Yes, we have patents to protect our IP. That's needed if you want to start up a robotics business. You need to have some patents. There are a lot of patents in robotics at the moment. The number of patents is rising very quickly. And yes, we need patents, unfortunately, I would say, to convince investors that this technology is worth investing in. If it were up to us, we would prefer to have open science where we could share the results with everyone. But unfortunately, the economic reality does not allow us, or not always allows us, to do that, certainly if we want to do a spin-off company. Okay, I think that's the most important ones. Unless there's someone else that has an urgent question. No? Okay, thank you very much.
Okay, now it's time for a mover and shaker in the Belgian field of robotics. She's a software robotics engineer at Space Application Service. And already during her studies, she built her own 3D printer, and also she designed and built printable robots. So as you can see, she's very enthusiastic about developing things from scratch we are enthusiastic about hearing what she has to say. So please welcome Irene Sanz.
Okay, yeah, just let me know throughout the presentation. I'm gonna try to give you some of the information of the different projects I've been working on, but it's going to be very brief. So yeah. So yeah, if you have any more questions, you can just ask now, or you can ask later. Maybe when we have it. Okay, nice. Okay. This is not the first one. Okay. So yeah, the presentation. Yeah, the beginning I already did, so let's just skip back to it. So the university, what I did, I'm an electronics and automation engineer. I'm now 26, so I consider myself a bit old, so yeah, just bear with me. So while at the university, I already joined our robotics club. I've always been passionate about robotics. Like when I was very little, I used to unmount things and just build robotics out of wood and these kind of weird things that my parents were always crazy about. But I've always liked it. And while at the university, I started building my own 3D printer. So now I have my second one. This is a picture of me like a few years back. I also started in a robotics club, so I learned how to 3D print. I learned how to design in 3D. I learned some of the electronics, apart from what I learned at the university, of course. And really, I've been always passionate about robotics. Here you see one example of the TwinBot, which is a very simple robot, but it's fully 3D printed. Here I have a quick video of a demo of it. So the idea with this robot was actually to have like a platform to test different things. I don't know if you can see, but the upper part is actually where the sensors are mounted. So there you have ultrasound sensors. It's a very simple obstacle avoidance example. But the idea of this robot is actually that you can plug and unplug in a Lego-style configuration different sensors and test different things very easily. So this was one of the very first projects I've ever done in the field of robotics, and this was while I was at the university. Also at university, okay, here. I also, of course, I guess most of the engineers, if there are any engineer here, already know the RoboCup. So it's a competition that it's basically based on football. You can do it on software. You have also a robotics competition. This is something we've already worked on in the university. And while I was there, I started getting more and more interested in software, not only 3D printers and robotics, but also software. And that's mostly in the computer vision field. And in that field, I actually started developing some other projects such as Geeko. This project, actually, I did it together with a friend, and in it, what we try to do is detect the different postures of a hand and try to launch different commands so you can actually control your computer using just the hands. So these are just very few examples of the university. In this computer vision field, I also started working more in depth. I really liked it, so I did my bachelor's thesis on it, which is this project that I'm presenting here. So basically, it's an object learning and recognition software. This can be used in robotics. It's based on ROS, actually, so you can plug it in most of the robots that you can find nowadays. And in this project, in a very, very easy way, you can actually start learning new objects to detect, just pushing the hand forward a bit. As you see, this is the learning phase. And here I'm just learning two different objects. And when the objects are learned, the recognition system starts. So this was just to give you an idea of what I like, basically. Well, my main interest is in computer vision. And apart from the courses in the university, at least in my experience, the courses in the university are not really good enough to get to know really the hands-on experience that you need in robotics. So you really need to do these kind of things to really understand and be able to later work on the field of robotics. Okay. After university, so I started in a company that was called VQ. I'm just going to show you different projects of the different companies I've worked on. In this case, I started working in a 3D scanner. This is an open source printable scanner as well, so you can actually download all the files and print it at home and build it at home. This scanner, I worked for a few months, and I was actually working mostly on the calibration. So I got it to have really an error of 1 millimeter in the different scans. So it's a pretty good 3D scanner for being a printable one and not really a let's say commercial one. I've also, well, in this company, I came to be the smart toys department head of the smart toys department. In this company, I was managing more or less 20 people, and we were doing printable robotics. We were working on the 3D scanner I just presented. I actually programmed very easily a robot similar to the one that I showed you before, the TwinBot with the different sensors. So you can see here to the left side, you have actually the different boards. You can put there a robot. You can put there just an Arduino board or a similar board with different sensors. And with blocks, you can program it very easily. This software is actually now being used in Spain in high schools across the country. So this is something that it's still there. If you want to check it out, it's actually readblog.vq.com. I should have put the URL on. But yeah, if you didn't get it, you can just contact me later and I will write it for you. But this is something you can actually try it out at home. It's not only for kids, it's also for people that actually want to start programming and doesn't really have the technological background right now. There's also a code tab, so you can actually do more, complex things, not only the regular if-else blocks and these kind of things. So with Bitblock, we program this kind of robots. This is something that we developed as well. It's still available for sale. It's another company, previous company, so I'm not going to do too much promotion about it. But we developed different kind of robots for education. We also developed Zoe, which was actually the first toy that we developed. Per se, it's not only like a robotic educational robot, let's say, but it's more a toy, so it has its own app. You can actually do more programming on the app, but you also have some games, fun games, and more educational games. So you can have kind of a mixture between a toy and an educational kind of a robot. Okay, following that, some more, let's say, serious projects that I've worked on. OpenChair, for example. In this case, what we wanted to do is actually create and upgrade a regular wheelchair using a hoverboard. So all the parts that you see down there are actually the wheels of a hoverboard, and we modified the wheelchair with printable parts in order to make it usable and automatic, and have all the motors and all the controls. I also worked on Tabot, also reusing some parts and motors that I had at home. And the idea of Tabot is to have some kind of robotic assistant, so you can have it at a museum, just showing the different pieces and the different rooms to the people autonomously. I've also worked on dentistry, basically using 3D scanners to scan the different teeth and jaws of patients and be able to later design the implants and the pieces specifically for each of the patients. But the most interesting, I think, for this topic will be the space applications and services experience that I have. So in here, I've worked actually in very different projects. The first one is LoveMe, which you also can see there on person, so you can know a bit more about it. LoveMe is actually a robot that was thought to be kind of a lab on wheels, let's say. It has a drill, so you can actually drill on the moon. And the idea is to check then the volatiles that come out of that drilling to get an idea of what kind of materials are in that specific spot in the moon. So in this project, I worked very briefly. I think I was the the only woman probably, at least from SpaceUp side. And I work mainly, I'm now working mostly as a software robotics engineer, so I work mostly on the navigation part. So with the stereo cameras, just trying to get a map of the environment and trying to make the robot actually move through the environment. In this small video here, you see the deployment, which is pretty much what we had to do today to bring it here. And the first test run, yeah, there you see it moving a bit. This is the outdoors of the company. This is one of the first test runs. This was actually also tested in ESTEC, so in a lunar analog that it's in Norway, in the ESA, one of the ESA facilities they have. Other projects that I've been working on while in this company, it's mostly R&D and EC projects. So we're doing mostly R&D and and this kind of thing. So I've also worked in Infuse. This is a bit more complex to explain. So it's basically a framework for data fusion. What does this mean? So what we do basically is take data from different sensors or different algorithms, and we try to merge them together in order to obtain some kind of output out of them. It's usually to do to allow the robots to actually understand their environment and navigate and do different tasks in their environment securely. Infuse is actually open source, so it's an open source data fusion framework, and we've been developing it for 2 years. Here you can see some images for the Morocco trials. So we actually tested with different robotic systems. This is one of them. This is the other 2 robots that we were working on. So it was pretty cool. We went there like last year in October. So it was a very, very nice setup. Yeah, you can see here some part of the team of Infuse. Again, as this is women in robotics, I think I was the only woman in Morocco. That's for sure. I mean, I was like, how do people recognize me? And then I was like, oh yeah, I'm the only woman. Okay, that's how people actually know my name. So yeah, but it was really fun. I also presented it on Astra. So this was in the end of May. So it was like just a few weeks back. So that was the past, and this is the future. So where are we working now? In my company, and me personally, I'm involved in these 2 projects. So PROACT, it's based on the moon as well, and the idea is to have a system of robots actually constructing an ISRU plant, so an in situ resource plant on the moon. And in this case, we will have 2 robots and a gantry that will help lift heavy objects, and the idea is to show collaboration in this robotic system to be able to build a complex system in the moon. The second project that I have is called EROS. This is related to in-orbit servicing. So we have a servicer satellite and a chaser satellite. So some satellite that needs refueling or needs to be repaired, and another satellite will autonomously catch it and repair or refuel or do whatever task is needed. So these are the 2 newest projects that we will be working on. These 2 are also easy projects, so H2020 Horizon funded, and it just started. So we'll probably in next events, if there are any, I will do any updates on them. Yeah. Okay, so here's my summary of the challenges. From the technical perspective. So the first of all, keeping up with the state of the art. If there are any more engineers here, will know that there's an enormous amount of people just working on it. So you really have to study every day and be really, be really proactive in learning the new things that happens. There's a lot of different interesting topics. So I've done 3D design, I've done control, I've done software robotics, more related to computer vision. I've done a lot of different things. So if you sum that up with keeping up with the state of the art, it becomes crazy. So you really have to center yourself in something. Otherwise, it's going to be way too much. And now, more related to what I'm working now, so research projects in this kind of easy environments. There are big projects with multiple partners, so communication, it's a big issue. You have to really synchronize with a lot of people. You have to integrate a lot of technology and components, different components. So that's, for me, one of the biggest challenges. Moreover, coming from my previous experience in which I was mostly working alone or in a really, more reduced team. for each of the projects. So lessons learned, and I think this is the best, the key simple principle. This is something that I think the first day of my engineering course they taught me, keep it simple, stupid. This has been here forever, like from the 60s, I think, from the USA military. So keep it simple, that's the best principle. I think not only for engineering, but in life in general. That's just the best to follow, and never stop learning. There's so much things to do that you really have to learn every day, basically. So the future, I mean, this is our idea of future. That's the reality right now. So robotics is not only the industrial robotics we already know, it's not only the educational robotics I just talked to you about, it's not only the Roomba that you have at home, but you also have a lot of software that it's currently being developed for the autonomous cars, for the different, actually even police systems that actually identify you autonomously, this kind of delivery system. So robotics is gonna be there. I mean, robotics is already here, so robotics is gonna be there in the future. So we'd better just move on and get on the field. This is just a few statistics, so you know. These are the new jobs and the percentage of jobs that it's in the future. So you can see there in the stable roles, the robotics engineers is one of the principal ones that there is, and robotics engineer, innovation professionals, new technology, and automation specialists are really predominant in the future. I mean, we need people to actually program and develop these kind of robotic systems that we will base our lives on. And in the top 10 emerging, top 20 emerging jobs, you see there machine learning engineer. That's also used in robotics. It's not only the hardware, it's not only the regular software engineer. You also have deep learning, you also have machine learning to actually power the AI that we're working on now on the robotics field. I put here also big data developer and Unity developer. I know Unity is mostly for kind of video games, but it's also used in robotics in simulators, and simulators are very, very, very useful in order to see how your system is gonna perform in different environments and to create realistic environments in the end. These are a statistic of the proportion of women scientists and engineers in the EU. I'm almost certain most of these are scientists, because engineers I haven't seen that many. Couldn't find any for robotics engineer in particular, although I really searched for it. In my classroom, for example, I think we were 4 engineers out of 50, something like that. So it's still very, very small for engineers, and moreover for robotics. I think that the more specialized you go into like kind of a field, the less, you know, women there are. General software developers, I think there are way more than robotic engineers. Why is this? I mean, these are, I want to really point out some things that I think are wrong in our society kind of a mind. And one of them is engineer is for men or man-minded women. I'm gonna go ahead and tell you that I've been one of the women who thought that she was man-minded woman. I mean, I've said it so many times, but I think this is really bad. It's bad marketing for us. I mean, we shouldn't really think about man or man-minded women. We should just think about people who like something or doesn't like something. And I tell you that I did it a lot of times, and I'm, realizing my mistake now. Also, another thing that I want to try and put out there is engineering is boring and for nerds. I think this is not true. I mean, we have really this idea of engineer, the idea of the Big Bang Theory engineer, it's not really that. I mean, engineering, you have so many different fields, you have so many different choices that you can actually work on, that it's, I mean, there are some that are boring, I'm not gonna lie to you, but robotics in special, there are really, really a lot of interesting and fun jobs. So what I think we should concentrate is on the marketing. I mean, I think, this is completely my opinion, but I think there are not so many women in robotics because we don't market it good enough. I think we always think that the man is the engineer, this kind of antisocial man. and we should try to push it towards this kind of like Valentina, the first woman in space. I mean, she's amazing. We should promote more this kind of images of women, of successful women that actually know a lot and that actually did a lot. But not only that, I mean, those are amazing technological deeds, but we also need somebody like Simone Geertz doing shitty robots that everybody likes and everybody shares because they're just usually useless. But they're fun to watch, and that actually promotes a lot of kids to get an interest into the new technologies and into this field that is not really so frequented by women. Now, based on my experience, I've never had any discrimination. That's something that I wanted to point out. There might be other women who had. In my case, no discrimination whatsoever at university or at work. I would also point out that there are great communities of engineers and DIYs out there, so I would just suggest you go ahead, and if you're interested in it, just Google it. I mean, there is so much information on the internet and so many people very knowledgeable that really likes to share what they do, that you should just get in touch with them. And also there's, as I said already, lots of interesting jobs. Yeah, I will do it later. No worries. Just to finish, my recommendations. The first one, if you like it, do it. I mean, I wouldn't push it to the women. I mean, if they don't like it, you shouldn't push the technology or the engineering on women. We should just try and change the marketing and try and make them see what there is available, you know, and try to, yeah, let them actually decide if they like it or not. And the biggest one that I want to, if there's something that you take out of this presentation is this line, please, believe in yourself. And I'm not really telling you about like these kind of mugs or whatever that you can buy. It's not really like an inspirational kind of quote. I'm telling you with facts. And this is actually a fact that it has happened to me and it still happens to me. So as women, we're less likely to apply to the same job. So we only apply to the job if we have 100% of qualifications. Men do that if they have a 60% of the qualifications for the job. That's a fact. Yeah, we can ask. I mean, these are just these are just facts. And to be honest with you, I mean, I only got the job that I have now because my boyfriend pushed me to apply for it because I thought I wasn't good enough for the job. So this imposter syndrome is real. I mean, I suffer it. I mean, I didn't think I was good enough for it. I didn't think I was good enough for this talk. I still suffer it, you know? So I would, if there's just one thing that you take out of this, just believe in yourselves and go do it, basically. Thank you. Thanks. Okay. Okay, thanks. So let's try and answer some questions. If you have any more, just let me know now. What do you think, Prasanka? Okay, that was already answered. What are some cases of Gecko? Okay. Yeah, I mean, the advantages or use cases of Gecko. So Gecko was basically developed as a prototype technology, but that could also be used in things like cooking, which is a very common thing that we do, or also in like medicine, in places basically in which you cannot touch something to change from one screen to the other. I also developed something very similar like Gecko in order to pass the different chords of while I was playing the ukulele, so I didn't have to actually press some buttons. So there are a lot of use cases like this one in which you cannot really use your hands, or they have to be clean or whatever, that could be useful for an application like Gecko. Any advice on how to get more young women into robotics? I would say, at least in Spain, I'm not so sure about Belgium, but at least in Spain there is now a robotics course that it's mandatory for all the teenagers. So there's like in technology and robotics now. So they kind of force you in school, in high school, to program and to start building robots and this kind of thing. So I would suggest just show it to them as a game. I mean, just show it to them as a game, and if they're interested, they can follow up in different courses and online and whatever. But there are a lot of, not only the ones that I showed you, the educational toys, but there are a lot of toys in order to introduce people to programming. So I would start with that. What can dads do to encourage? That's a good one. Actually, my dad is a handyman, so in that sense, I'm an only child, so I've always been like hammering things and screwing everything. So I think just try to not impose the social vision of what a woman should do and a man should do. That's enough. I mean, just ask your child, do you wanna screw this? Do you wanna help me fix this? I think that's good enough for any kid to see that it's normal for women to do that, and that if they like it, they should go for it. I think that's the best. Okay. If you have any more questions, if not, I'm over there in the space application stand, so you can always come and ask. Thank you.
So now we ask you to describe the event with one word or with multiple words, but one at a time, using the same website, Slido. So at the end, we will have a cloud pool with all your words.
Just to kind of, I can summarize a bit of the words you use here. So we can see interesting, inspiring, empowering, jobs, okay, sunshine, confidence, motivational, fascinating. More women in robotics, that's true, we need more women in robotics. Brave, enriching. It's, okay. Great, changing world, excellent, enlightening, and so on. Thank you everyone for sharing, your insight about the event. This motivates us to do more and to give more. So keep an eye on our social media. We are preparing other innovative events in the future. And yeah, I think the message from this event today is that, it is important that we have more women in not only this field, but in any other field. And we need to work together. As Iran said, it's not about women or men, it's about working together for a better humanity, for a better future. We are living in a quite interesting evolving present, and the future, we don't have like clear idea how it would look like. And I think we need more collaboration and empathy more than any time before in the history. So thank you for coming. You have some food and drinks there. Make sure to have fun. Enjoy, the rest of the networking session. Thank you.